This is Precalculus on-ramps, Unit 8, chain rule. We've got an interesting, I think I'll do a couple of these. And remember, chain rule is if there is some kind of composite function, and it could be many composite functions if you have f of g of x. Let's say that's the function h of x, and I want to find the derivative of it. Then h prime of x is a derivative of the inside, which is g prime of x, times the derivative of the outside, f prime of g of x. And you can have function after function nested together. You just have to go inside, outside. Some people go outside to inside, but you got to take the derivative of this and then the derivative of this whole thing and multiply them together. All right, let k be a constant and f of x equals 3x plus k to the third power. Find the value of k at which the graph, is k a constant? Yes, k is just a constant, at which the graph of y equals f of x has a tangent line with a slope of 1 when x equals 2. So I'm going to take the derivative and then plug in 2 for x and set it equal to 1 and find out what k has to be. So notice this is a chain rule because I've got a function inside. The derivative of that inside function is 3, and then a function of the outside, 3 times 3x plus k to the second power. So I have to just, and I'll show it again in a second. So I want the derivative of inside. K is just a constant, so the derivative of a constant is 0, but the derivative of 3x is 3. This is f prime x, by the way. Then I'm going to find f prime of 2, and I'll set it equal to 1, times. Now, I act like this whole thing is k, not k, x. That whole thing is x, so this is like x cubed, but x is 3x plus k. And so I'm going to put 3, this is the power rule, 3 times 3x plus k. I'm just pretending that's one big variable. And then 3 minus 1 is 2 using the power rule. So this comes out to 9 times 3x plus k squared. And notice some of these have 2 answers because this is squared. So I have to set that equal to 1. Now I will divide by 9, 3x plus k squared equals 1/9. And now I will take the square root of both sides to get rid of that square. 3x plus k equals plus or minus, and then the square root of 1 is 1, the square root of 9 is 3. So 3x plus k equals 1/3. I'm going to solve both of these. 3x plus k equals negative 1/3. And then, what was it again? When x equal 2. So now I'll plug in 2. This is, I want to find f prime of 2, and I want it to be equal to that 1. So I'm going to put 2. 3 times 2 is 6, plus k equals 1/3. K equals, I'm subtracting 6, 1/3 minus 6. I can rewrite 6 as 18/3. And 1/3 minus 18/3 is negative 17/3. Which answer choice has negative 17/3? This one doesn't, this one doesn't, this one doesn't, this one doesn't. The answer is E. But let me just double check it with this one. Again, put in 2 for x. 6 plus k equals negative 1/3. K equals negative 1/3 minus 6, which I can rewrite as 18/3. Negative 1/3 minus 18/3 equals negative 19/3. And I just verified E. If it had come out to something different, then I'd have to maybe rethink. Maybe I made a mistake on the first part of that. But there's the answer. So multiple choice can make things a little bit easier. Let me do one more chain rule. And let me do this one because this has an interesting function. Notice there's a function inside, there's a function outside. So I want dy dx. And so remember that this inside is a quotient. So if f is x, f prime is 1, and if g is x plus 1, g prime is just 1. So now I have to do the outside, but then I have to do the inside, which is quotient rule. So f prime g, it's 1 times x plus 1. I'm doing the derivative of the inside thing first. Minus g prime x, minus 1 times x, all divided by g squared, x plus 1 squared, times the derivative of the outside. I'm acting like this whole thing is just one big x. So it's going to be 5 times x over x plus 1. And then 5 minus 1 is 4. So let me see what I've got going on here. This is x plus 1 minus x. So that's just 1. 1 over x plus 1 squared times 5. And I'm going to separate these. I'm going to make this x to the 4th divided by x plus 1. To the 4th. And I get 5x to the 4th divided by 2 plus 4 is 6, x plus 1 to the 6th. And that is answer D. So that's chain rule and quotient rule. I had to do both. I guess I'll do one more of these. Let me find this one. So this is, I'm going to rewrite this, g of x, just so it's very clear what I'm doing with the chain rule, equals 2 times sine of 3x squared. So notice I've got this function is inside, then this is inside, then this is the ultimate outside. So I got to do chain rule 3 times. Sine of 3x is 3 times. Then this is sine of 3x as if 3x was just a one big variable. And what's the derivative of sine? Cosine. So cosine of 3x. Then I have to act like this is just one big x. So 2 times 2 is 4. And then sine 3x. 2 minus 1 is 1 to the first power. And now I want g prime of pi over 4. So this is g prime of x. Now I just plug in pi over 4. G prime of pi over 4 equals, well, 3 times 4 is 12. Cosine pi over 4 times 3 is 3 pi over 4. Recall your unit circle. Let me show you the unit circle. All it's going to do, it's going to be pi over 4, but maybe the sign's going to be different. It's in a different quadrant, but I just want to show you your unit circle. Hold on, why isn't it pulling up my unit circle? I just want the unit circle, please. Okay, that's not working. Let's try this one. No, I can't get the unit circle big. Hold on. We'll get it in a second. Ah, here we go. Here it is. 3 pi over 4 is right there. And the cosine is negative, see? Because it's in the second quadrant. So you just have to remember that. Let me get back here. So this is times negative square root of 2 over 2. I've already done the 4. And then sine of 3 pi over 2, well, unit circle, that's positive because it's in the second quadrant. That's positive square root of 2 over 2 times square root of 2 over 2. And so this is square root of 2 times square root of 2 is 2, negative 2. So 12 times negative 2 over 4, which is 12 times negative 1/2, which is negative 6. So chain rule. You go from the inside out.